Today I'm going to do something a little bit different that I've been planning to do for a long time, but never got around to it until now. I'm going to find an article online. Well, actually, I already found it. And critique it. And the cool thing is, they provided their data, so I can actually analyze their data. So here's my plan. I'm going to first read through the paper, and that way I understand what they're trying to do. And then what I'm going to do is I'm going to try to replicate the results that they report to make sure that I'm understanding the variables right. And then I'm going to give feedback. And I got to be careful about this because my nature when I read a paper that is not written by a statistician is to get upset and annoyed at how they analyze their data. And I don't want to call out the authors of this paper, and I don't want to punish them for making their data freely available. So I'm going to try to put on my filter and be kind to them. But I'm also going to be honest. And I guess in some ways, I shouldn't have to apologize if I disagree with the way that they do things. And I shouldn't have to worry about disincentivizing people to publish things online, because that's why you publish things online, so that you can be scrutinized. But I'm also aware that these people could feel like they're being called out, which, again, that's not my intention. Anyway, so I'm going to read this article and get an understanding, and then I'll come back and then give you my thoughts. Apparently the audio from my camera is terrible, so I'm just going to summarize what the article says. Basically, they propose that air pollution causes negative emotions, specifically regret, which influences people's stock trading behavior. And they got various measures of stock trading behavior. So what they did was they had a bunch of participants. I think it ended up being about 30 in 3 different groups. One group was exposed to air pollution via mosquito coils that were releasing particles in the air. Another was by burning straw, and another one was a control group where there wasn't any sort of air pollution. And then they had the participants engage in a stock market fantasy sort of game. And in the process, they recorded various outcome variables. If you're interested, you can read the paper, but I don't understand them enough to communicate. But basically, there's a couple of primary outcome variables that indicate bad trading behavior. So at the end of the day, they're trying to determine whether the 3 experimental conditions, the 2 pollution conditions and the control condition, whether that experimental effect influences people's trading decisions, specifically their bad trading decisions. And also eventually, toward the end of the paper, they want to see whether that is mediated by regret. Hello again. So it's the next day. And I spent a lot of time yesterday trying to reproduce what they did, and I got the vast majority of it. So let's go ahead and step into R, and I'll show you my results compared to their results, and then give feedback on what they did along the way. First thing I'm going to do is reproduce table 2. Okay, so table 2, frequency analysis of irrational decision-making behavior. And so this script will do that. I'm not going to run through my R code just because this isn't an R video, but if you compare this to what they have, I mean, the order of it is a little different. Let's see. But you see that I get the same results. So, for example, they've got realized gains. We got 118, 144, and 47, which is the same as what they have, and then the proportions end up being identical. So, cool. Now, the problems with this is this treats each person as if they're independent when they're not. So yeah, it's just summing across all people regardless of whether they are the same person or different people. That's kind of a problem. You violate the assumption of independence, which is bad. But of course, in this table, we're not making any inferences, so the fact that we kind of ignore the assumption of independence isn't problematic until we get to table 3. So if we want to reproduce table 3, we get the same results that they get. My table is not as extensive because I was just trying to reproduce the p-value. So now, my problems with what they did. Again, like I said, they're treating data as if they're independent when they're not. Second problem is more of a question. So They dropped one of the experimental conditions to reproduce table 3, the MC mosquito coil condition. Why? My assumption is they didn't know how to do a Friedman test, which is the non-parametric equivalent of an ANOVA. So they didn't know how to handle 2 groups, so they just dropped one of the groups, because then in table 4, they do the exact same analysis, except they do it for the ST, the straw experimental condition, which is kind of weird. Why don't you just put them all together? And the third critique is, why didn't they just use a chi-square test? Because you have 2 count variables, experimental condition, and then these realized gains, paper losses, etc., etc. Those are both count variables, so why not just do a chi-square test? If you're going the traditional route. Of course, that still violates the assumption of independence, but that's a better way of analyzing it if you're going to violate the assumption anyway. So when I reproduce table 4, I am actually creating a new column called chi-square that gives you the chi-square results. And you'll see that the chi-square is more conservative, not substantially more. I mean, in this case with per down, it's double, but still, I mean, the substantive conclusions you reach would be the same, because that's below 0.05, so is that. These are not, these are not. So the conclusions wouldn't change, even if the p-values are slightly different. That's weird. Now let me reproduce table 5, which is Mann-Whitney-U of the disposition effect and repurchase effect between the ST group and control group. So again, they're excluding one of the groups because probably they didn't know how to do the Friedman test or whatever. So if I run that, I get the same results that they get p-value wise, or close to it. It's not exactly the same, and that was a problem that I found multiple times, is that my results were very, very similar, but not exactly the same. And I suspect what is happening, because their data set, they have an Excel spreadsheet with the raw data and then like summarized data. So I'm guessing what they did is they summarized the data and then rounded the data, because eventually you're going to have to round things anyway. And then they analyze the data, and so it's analyzing rounded data, whereas R is not analyzing rounded data. It's only reporting rounded data. So I suspect it's just rounding error, but I don't know. The other comment that I have, this is probably one of the best things they did, or one of the least problematic, I should say. This isn't terrible, because on this data set, what they did before they produced this table is that within each person, they summarized or aggregated all the data per person. And so at this point, they're analyzing cross-sectional data, or they're analyzing data where one row represents one person's score. So they're no longer violating the assumption of independence, so that's good. So this is almost a legitimate way of doing things, except they're dropping an experimental condition. And at this point, I probably wouldn't object to a Mann-Whitney-U test at least as much, because what ends up happening, so here your outcome variable is a proportion, and it's a bad idea to analyze a proportion with a linear model. But I don't think there's a problem with analyzing it using, like converting it to ranks and then analyzing it, which is what the Mann-Whitney-U does. So I think that's probably okay. But again, you're dropping an experimental condition. Other than that, it's probably okay. And if I try to reproduce that table, I get p-values that are very similar. I think I already said that. All right, now to figure 2. Because I'm a plotting guy, visualization dude, I certainly have a lot to say about this. So I reproduced what they did. Of course, mine are not going to be exactly the same because they're using their software, I'm using my software. But here are some problems with the way they plotted things. One is that they have both a legend and an x-axis label. Why? That's totally redundant. Either have a legend or an x-axis label. I guess you can say it doesn't hurt to have both, but you don't need both. It's just kind of silly. Number 2, and this is a problem that everybody does, is that they put these little whiskers. That's what those little intervals are. Some people call them whiskers. At least Tukey called them whiskers, I think. And I don't know what those whiskers represent. Are they the interquartile range? Are they confidence intervals. If they are confidence intervals, are they 95% confidence intervals? Are they 97% confidence intervals? Are they 67% confidence intervals? Or maybe they're standard deviations and they don't tell you. And what I did was I did 95% confidence intervals and they look really similar to what they did. So I'm assuming they did 95% confidence intervals. Problem number 3 with their plot is they don't have any raw data. So I always plot the raw data. And actually, I'll go ahead and show you that right now. If I were to plot this, it would look more like this, where you see each of the raw data points. So you can know whether that mean is actually representative of the entire population. If you don't have the raw data, then you don't know. And it also communicates information like concentration of scores, as well as sample size. So, no raw data, that's problem. Number 4, using a bar chart for the repurchase variable is misleading. And the reason why, so when you use bars, they should only be used for count data or proportional data. Like if you're talking about like 90%, 80%. And you might look at the y-axis and say, hey, that looks like proportional data, but it's actually not, because what these values represent is they represent differences in proportions. And so it's possible to get a negative value, which actually happens, if I look over here, for the repurchasing. Actually, no, it happens for both of them. Both variables have values that fall below 0. And so it's very misleading to have a plot that shows it starting at 0, when in reality, it can start below 0. So these are just misleading. These aren't the right plots to use. And then, again, why would they remove an experimental condition? Again, it's probably because they don't know how to do the actual analysis that would involve that condition. And so here's my version of the plots that I think are way better. So these bands represent interquartile ranges, and what are we seeing? We see that disposition and repurchase, these two variables that indicate bad trading behavior, they are slightly higher than the control condition, especially with the repurchasing. So yeah, that's cool. Now let's reproduce table 6. Okay, so this is just basically doing more Mann-Whitney U tests on a bunch of different variables related to bad trading behavior. That's the PGR, and I don't even remember what all these variables mean, but I was able to reproduce it. And that looks like this right here. And once again, my p-values are very, very close to theirs, but not exactly. Again, probably because of rounding differences. And all the criticisms I've had would apply to this as well. Okay, now we go to table 7. And this is where the problems really start. It gets kind of bad here. So first of all, I was looking at this, and so remember, we've got 2 experimental groups and a control group. And then when you look at their table 7, they are reporting coefficients. And if they're reporting coefficients for a variable with 3 conditions, there should be 2 coefficients. For example, 1 coefficient for the MC group and 1 coefficient for the ST group. And you wouldn't need 1 for the control group because that's covered by the intercept. Anyway, details don't matter. But in their table, they only have 1. So what happened to the 3rd group? And so this took me a while to figure out. I was like, okay, maybe they dropped one of them. And I tried doing that, and things just weren't working out. And then I said, I wonder if they just combine them into 1 group. And there's some hints there because they call the variable pollution. So I'm suspecting that they're saying any pollution belongs to this group. And so when I ran that analysis, sure enough, I was able to replicate the results. And that's the sort of thing you need to tell people. Like, if you're running the data and combining the 2 groups into 1 group, you should be telling people that. But that's not the least of the problems that we have here. So, when I combine, I end up getting a table that looks very similar to theirs, except it's not identical. So I've got like negative 0.138. They've got 0.135. The direction doesn't really matter in this case because it's a binary variable. So You could either say you are, like in this case, the control group is 0.138 points lower than the pollution group, or if you code it so that the referent group is the control group, then you could say that the pollution group is 0.138 points higher. That doesn't matter. And likewise for some of these other variables. And so getting very similar results, but not identical. Again, I've got 0.001, or 0.002, they got 0.003, but they are very close. I did notice that the intercepts, so they call it constant in their paper, I call it intercept, they got 0.445, I got 0.505. They've got 1, I've got 0.078, and I could not figure out why my intercepts were different. And that's the only one that I really looked at closely other than this one. R squares end up being fairly similar, but not identical. Sample sizes, they are identical, so that's good. That's a pretty objective measure, so I would hope it would be similar. So yeah, able to reproduce their table 7. Now, some additional comments. One, good thing, they're not violating the assumption of independence because, again, it's aggregated within person. So once you've aggregated within person and then you're analyzing the proportion of each of these variables per person, you're not violating the assumption of independence anymore. So that's good. But big problem, you can't predict proportions with the linear model. So they're using just regular regression and they're trying to predict an outcome that ranges from usually 0 to 1. When you're fitting a straight line, it's going to predict value. It's very likely it's going to predict values that exceed 1 or go below 0. And so the linear model just isn't the right model for that. And that can lead to some major problems. Number 3, I already talked about that, just the numbers are slightly different. I suspect most of it is due to rounding error, but I can't figure out why the intercepts would be different. Some other major problems with what I see. Number 4, why are they looking at these specific covariates? So when I look at their original data set, there's lots and lots of covariates that could have been used, but they didn't. Instead, they used these specific ones. Why these specific ones? I don't know why, and they don't explain why. My worry is that they use those specific ones because they gave them the best results, in which case they're p-hacking, phishing, whatever you want to call it. I hope that's not the case, but maybe it is. And then my final criticism is that anytime you use a covariate, you try to control for something, you have to make sure that that covariate doesn't interact with the variable of interest. In this case, pollution. Because if it interacts, then it biases your entire model. And I very much doubt whether they actually investigated that. So, that's something to be wary of. Okay. Now that alone isn't that bad. I'm gonna go on a little bit more and then it's gonna get worse. So table 8, I ended up just reproducing their p-value, which ends up being very similar to what they have, if not identical. So that's good. And so what they're doing here is, okay, I guess I'll just jump to this part. So they're trying to do like a mediation analysis where you've got, let's see, what are they trying to, I'm gonna pull up the graphic. They're trying to say that air pollution causes regret, which causes them to make these bad financial decisions. And so they want to do a mediation model. And what they end up doing is they end up looking at this path, which they call A, but it's traditionally called C. And so they're trying to predict these financial behaviors from air pollution. Okay, fine. And then they do another one where they try to predict regret from air pollution, which I'm going to show you that in just a minute. And then do that model. Fine. And then they do another model where they look at regret and the financial decisions. Fine. All that's fine. But they never combine those things and then compare them across. Like, in order to do a mediation analysis, you have to establish this path, and you have to establish this path, and you have to see how this path changes once you include the regret variable in there. And they don't do that. They just run these models independently and try to use that as justification for a mediation model. And that's not how mediation models work. So totally wrong way of doing a mediation model. But there's even more problems. Okay, so table 8, I'm going to reproduce that. This is predicting regret. Nothing is terribly problematic here. And so because you've got, again, using traditional means of statistical significance, which I'm not a fan of, but whatever, using a p-value, we can say, all right, we can predict regret from pollution, and that's one of the essential characteristics. You have to be able to do that in order to do a mediation model. We're okay there. And then now we go to table 9, and this is where it gets really weird. They have this new variable that they introduced called hint. And if you do a Control F or Command F on this paper, there's like two places where they mention the word hint, and it's all in the results. So they never mention the variable hint. Why is this variable suddenly showing up? And if you do read the paper, actually, I'm going to go back there, because I reread the paper after I saw this, and I'm like, what the heck is where is this hint thing coming from? And then I remembered reading on page 5. So they have, if the stock price increases, it's probably going to increase the next time. If it's decreasing, it's probably going to decrease the next time. And so it says that we remind the subject of the most likely direction of the stock price change by displaying a positive and negative, or an upward and a downward arrow on the computer screen. So basically they're saying that for the subjects, every single time it's going to show an arrow indicating this is probably going to keep going up, or this is probably going to keep going down. So maybe that's what they mean by hint, but they don't say that they varied that. They say that it seems to suggest that it happens every single time. And so if you are including a variable called hint, but it happens identically for every single subject, it's not a variable and you can't model it. So I have no idea what this hint variable is. It's really weird. So my biggest problems with that is A, there's no variable called hint in the dataset. B, why are we introducing that just now? And why do we not know about it just now? And I think I have some suspicions about what happened. So if I were to model realized gains from regret alone, which is that path, it is non-significant. Again, I don't care about significance, but they do. And so I'm suspecting what happened is that they saw this and said, oh shoot, it's not significant. Hurry up, find some variable that might be a suppressor variable. And so maybe they auditioned every single variable in the model and finally found one called hint, which I still can't find, and said, oh, there we go, now the effect is there. And that speaks to something else. It's very strange that when they're trying to establish this path, they use all these covariates. But then when they're trying to establish this path, they use no covariates. And then when they're trying to establish this path, they use a brand new covariate. Like, what's the rationale behind all these different conditioning effects? The only conclusion that I can think of that's reasonable is that it was p-hacked. That they're like, all right, that path didn't look very good, so let's add a bunch of covariates. Hey, it looks good now. This path didn't, actually, they didn't have covariates in that path, I think. And then this path, and like I said, there's this huge problem with this, where'd this hint variable come from? And so, I'm not an expert in mediation analysis, but I'm pretty sure that if you are using covariates in a mediation analysis, you need to at least do things consistently. You can't have some in one part of the model and some in another part of the model. That just doesn't make sense. Okay, so this is a hot mess. And again, I don't want to be in some ways, of course, I'm critical of these people because it's my job to be critical of these people. But I'm not critical of them as people. This is what happens when you have non-statisticians analyzing data when they don't have enough training to analyze the data. And some of these errors are very basic errors, like, why aren't you using the chi-square test? Why are you using a Mann-Whitney U? Or why would you use a Mann-Whitney U when you should be using a Friedman? Like, you don't just eliminate experiment groups so you can do a t-test. That's basically what they're doing. They're eliminating one condition to do a t-test, and then eliminating the other condition to do another t-test. Why are we doing this? It doesn't make any sense. But this is what happens when you have people who are not trained in statistics who are expected to do their own statistics. You make all sorts of bad decisions. So if I were to summarize all the problems that I see with this article, I would say probably the most severe violation is probably the way that they did the... Well, it's probably the p-hacking. And I don't know if it's p-hacking. It's the inconsistency of the covariates in the mediation model. And then second most is that the way that they did mediation is just not the right way to do mediation. And then third, probably the violation of independence. And then fourth, it's just that they're using the wrong test. They're using a Mann-Whitney U when they should be using a chi-square or a Friedman test. So, yeah, if I were a reviewer, I would absolutely reject this paper. I think this video, I suspect this video is getting really long, so I'm not going to show you how I would analyze the data just yet. I'm going to save that for another video. And it would be interesting to compare the results that I get with the results they get and see if they're the same. So, I implore you, if you are doing your own analysis, know what you are doing. If you don't know what you are doing, consult a statistician. If you don't know what you're doing, but want to know what you're doing, then hey, guess what? You can take a class from me. I offer both live classes, where you get to interact with me via Zoom every week for about 2 hours, which is pretty awesome. Or you can take self-guided classes, where you can learn at your own pace. And I am rushing to publish this video because I have a class that starts on Monday. And we still have a few, not many, slots left. And so if you want to join my Simplistics class, I invite you to go register there. I will leave a link in the description. And I hope to see you live. So yeah, that's all I got for today. Next time, I'm going to analyze the data my way. And we'll see how my conclusions differ from what the authors concluded. Yeah, that's all I got. Peace out.